So this section, we're learning about one of several points of concurrency. And a point of concurrency in a triangle is just a point that's the intersection of multiple lines in the triangle that have a special quality. Okay? In this section, we're learning about a point of concurrency called the circumcenter. And the circumcenter is created by the intersection of all the perpendicular bisectors in a triangle. How many perpendicular bisectors are there in a triangle? 3. 3. Someone tell me what a perpendicular bisector is. It's got 2 features. What's that? Okay, they'll cross at the midpoint at a 90-degree angle. Okay, so if I've got a midpoint here and it goes through a 90, I really don't want to draw an equilateral triangle. Somehow I was able to do that. Okay, so if I go through the midpoint, pretend, and I'm going to draw a perpendicular line through that midpoint. Okay, so it doesn't necessarily go through the vertex. Sometimes it will, depending on the triangle, but that's not one of its features. The feature of a perpendicular bisector is that it goes through the midpoint at a 90. That's a perpendicular bisector in this triangle. Okay, so the circumcenter, if I do it on all 3 sides and I just go through at a 90, and I go through at a 90, we're going to be close. That point right there, where they all 3 intersect, is called a circumcenter. Circumcenter, and a circumcenter is a point of concurrency. All that means is it's a point where 3 lines in the triangle cross, and those 3 lines have a special feature. Okay? In a line, if I have the perpendicular bisector of a line, midpoint, perpendicular bisector, if I pick any point on that line, that point will be, and draw a triangle, this distance and this distance will be equal. So when I look at this triangle, the circumcenter means it's equidistant from the vertices if I find the circumcenter. Okay, so there's 2 pieces to this. How I find the circumcenter and what it means. How I find it is I take all of the perpendicular bisectors and find the point they cross. When I find it, it means that distance is equal to every vertex in the triangle. But notice that the lines to the vertices weren't the lines that created the circumcenter. You follow? This line had nothing to do with finding the circumcenter. It happened after. Once I found the circumcenter, I now know the distance from here to here is the same as from here to here, is the same as from here to here. That's what the circumcenter tells me. Okay? So what we're going to do is we're going to learn a program in this chapter called GeoGebra. On your computers, go to Google and just type in GeoGebra. G-E-O-G-E-B-R-A. When you do, you're going to get a couple choices. I want you to go to GeoGebra Classic. GeoGebra Classic. We're going to learn this program because I'm going to give you a project this chapter that if you do it could take the place of a quiz grade. If you do it and you do well on the quiz, I'll give you extra credit for the project, so you can take your choice on how you want it. Okay? But you're going to be using GeoGebra to do it. So as we go through this chapter, I'm going to be teaching you how to use GeoGebra so that when you come to the project, you'll understand what you need to do. Okay? So what I want you to do, there's a couple of ways that we can, does everybody have like a flashing screen here at the top going? Okay. So if I want to make a point, let's just pick a point. So you click on the point, and then click point, and you can actually just put the point in right there. So just put in 3, 4. And I'll do the same with you. Okay, now do 5, -2. And then let's do -3, 2. I'm making these up, so they may not come up with. Oh, I need to make sure I put parentheses around that. Hold on. Come on. -3, -2. Okay, so I've got 3 points. I want to go ahead and make a triangle. So I'm going to click on the triangle button at the top. And then I'm going to click on where it says polygon. Just click on polygon. And now all I have to do is just touch my 3 points, and then go back to my starting point, and it'll draw my triangle. So I clicked this triangle button. Then I selected polygon. And then I just touched the 3 points, and you should get a triangle. End up back, you have to touch it 4 points because you go back to the original vertex. Everybody have their triangle. Anybody need help?
Restarted the whole thing because I noticed at the time point.
I gotta see what my points were. 5, -2.
And do I press enter?
Mm-hmm. You have to put it in parentheses. You have it in parentheses. It says just press, yeah, and there's your point. And then enter, and it'll take you to a new one. The new one, 3, 4. And -3, -2. Did you figure it out, Sierra? You good?
And then I did.
Okay, and then go to polygon, yep, and then polygon, and then just touch the 3 points. And then go back to the vertex you started with, all the way up. There's your triangle. Okay? Go to, yeah.
Oh, and never mind. This is totally off topic.
Okay, let me get through this. Okay, so tell me again how I find circumcenter. Yep, you were all saying it. The point where all the perpendicular bisectors meet. So what I need to do is find the perpendicular bisectors in this triangle. So what's the first thing? If I were going to have to find the perpendicular bisector, what's the first thing I need? Find the midpoint of each side. Everybody agree there? Okay, so to do that, go to this where it says letter A, that point. And you see where it says midpoint? When you click on it, there's kind of a drop down. Click midpoint. Now it's wanting me to pick 2 points that it wants to find the midpoint of. So just pick A and B. And then a midpoint should pop up. Did it work?
No, I have no idea.
Where's your triangle at?
I don't know.
Why did you?
Oh wait,
What
there's
are
a back
these?
there.
Keep going. Okay, wait, now you're erasing your points. Okay, now click this, and then
gosh.
polygon, and then connect them again.
I accidentally pressed. Okay, so where's
Okay.
the drop down arrow?
Right, you have to click that point A. Nope. Click that again. This point A, and then it says midpoint. And then you're going to just pick 2 points. and it'll show you the midpoint. Okay?
And can I do that? Do I have to
Yep.
click
Yep.
the
So
whole thing?
nope. Now that it's already selected with midpoint, so do the other two sides. Everybody do that? Yep. So you don't have to go back to that. It's already selected. All you have to do is click this, and it shows, and then this, and this, and it shows. Are we good there?
Wait, how do you want us to do the inputs for all of it?
Yeah. But you shouldn't have to re-select that point A. It should already be set to midpoint. So you just click 2 points, it finds it, click 2 more, and it finds it. Sierra, are you with us? Okay. So at this point, I found the midpoint. Now I've got to find a line going through that midpoint. Okay? So when you go up here, do you see this? There's a red line and then, okay? Just click perpendicular line. Okay, and it's going to want a point and the line. So you're going to touch two things. You're going to touch the point and the line. Huh? Why I want it? Point, line, and then it'll draw in your perpendicular line. Okay, do it to the other two sides. Point, line, point, line. Maybe. Just perpendicular line.
Oh, okay, that's what I was doing.
Because we've already found the midpoint. Okay. You guys have this? Do you have this up?
Yeah.
Okay. And you're good, Sierra? Okay. So that point where all three of these intersect, what is it called? The circumcenter. What I want to show you now, click circle. Click circle. Okay. We want this point here where it intersects. Where is my circle now? There it is. And you drag it until you have it intersecting the vertices.
So you just click
Huh.
circle, or do you?
Yes, just this.
I'm going to do it again. I'm going to try it with my mouse. So you click circle. And circle with center through point. And I click this. And it drags until it intersects. This is why the circumcenter is called circumcenter, because what we say is this circle circumscribes the triangle. The circle that's created here circumscribes the triangle. What do we know about the radius of a circle all around the circle? If I tell you that the radius from G to A, because that's a radius, right, is 3, what do I know the radius is from G to B and G to C? 3. This is why the circumcenter is equidistant to the vertices of the triangle, because those are the radii of the circle. Does that make sense? Yeah. So when you draw your circle in, this is just to illustrate, okay, that once I know the circumcenter, I know the distance from G to A, G to B, and G to C is the same. So this is going to start looking a little complicated, but what I want you to do now is go to the segment, click segment, and I want you to start at the center, G, and go to each vertex. Start at the center, G, and just draw a segment to each vertex of the triangle. Everybody with me?
Click the circle.
So G.
G to the vertices. G to C, G to A, G to B. And look at the last three segments that you just did. On the left side, it tells you the distance from G to C, G to A, G to B. What do you notice about the distances? They're the same. So we drew the circumcenter by connecting all the perpendicular bisectors of the triangle. Once we have the circumcenter, we know the distance from the circumcenter to all the vertices is equal. Follow? The other cool thing about circumcenters, I'm going to pull up a different window. You don't need to do this. Actually. Oh, crap. Okay, this is just GeoGebra. Someone programmed GeoGebra to kind of illustrate this. What I'm going to do, this is a 78-degree triangle. So what kind of triangle is it? Acute, obtuse, right? Acute triangle. I'm going to just slide this and show you. First, it finds the midpoints of each side. Then it's going to draw in the perpendicular bisectors and show you the circumcenter. And then from there, you see, once you know the circumcenter, you know that it's equidistant, okay, from all three vertices. What happens when I make this a 90? Almost. Use my mouse. Oh my goodness. Come on. When it's a 90, did you notice whether it was acute, the circumcenter was located inside the triangle? When it's a 90-degree angle, the circumcenter is located on the hypotenuse at the midpoint. On the hypotenuse at the midpoint. Hypotenuse is the length of the triangle that's opposite the 90. Okay? Yep. When it's acute, or when it's obtuse, as we keep going, look how the circumcenter just gets bigger and bigger outside. So acute is inside, right angle is on, and obtuse angle, the circumcenter is located outside. Regardless, though, once you find the circumcenter, you can still draw those three lines to the vertices, and those three lines will be equal, no matter where it's located. Good there? Okay. I want to give you something, and then we're going to do a sample problem because you don't get to use GeoGebra on a quiz or test, unfortunately. So you'll want to know how to do all of this manually. The sheet I'm passing out is just going to be a really good sheet to hold on to. As we keep learning more points of concurrency, this will be something you want to hold on to, and I might even let you use it on a quiz. But circumcenter is the second one in. That's what we're learning first. And it's formed by the perpendicular bisectors of all the sides. It can be inside, on, or outside the triangle, depending on the size of the triangle. It's the center of the circumscribed circle. And once you know the circumcenter, it's equidistant from the vertices of the triangle. So all of this I'm just reading right off of the sheet. So as you start learning all of these points of concurrency, you're going to need to know the information on this sheet. Okay? So let's go through and do a problem where we're looking for the actual circumcenter, and you have to find the point. And I'm going to just pick points here and hope that they come out somewhat even. So this is 3, 4, and this is 1, -2, and this is -5, 2. Okay. And you're going to have to know how to do this for the test manually. So pay attention. Interact with me when I ask questions. Okay. What's the first step? Find the midpoint of the three sides. How do I do that if I don't have GeoGebra to tell me what it is? Not the distance. Midpoint formula. What's the midpoint formula? Anybody remember? Mm-mm. What is it? Yeah, it's the think of it as the average of the x's and the average of the y's. To find an average of two numbers, I add the two numbers and divide by 2, right? So just think of it, if you can't remember, it's the average of the x's, the average of the y's. Okay? So if I want to find the midpoint between these two, I'm going to average the x's. 3 plus 1 is 4 divided by 2. 4 minus 2 is 2 divided by 2 is 1. Let's see how close I was. Pretty close. There's the midpoint. Okay, we're going to do it. Now, when you're trying to find the circumcenter is going to be the intersection of perpendicular bisectors, right? To find the intersection of two lines, I don't really need 3 to do that. Because where two lines intersect, the third one will too, if it's truly the circumcenter. Does that make sense? So I just need to find the equation of two lines. I don't need to find the equation of all three. And I can pick which two sides I want to use. So I've already got the midpoint of this side. Let's just pick the midpoint of another. Let's do this side here. So I take -5 plus 1 is -4 divided by 2, -2. And then I take 2 minus 2, 0 divided by 2 is 0. So it's just -2 zeros. Pretty close there. Okay, so I've identified two midpoints. My goal here is to get the equation of the two perpendicular bisectors. Once I know the equation of those two lines, this is back to Algebra 1 stuff. Once I know the equation of those two lines, I'm going to set them equal to each other, because where they're equal is where that point is. Let me say that again. Okay, so my goal here, I just found the midpoints. I want to find the equation of the line that's the perpendicular bisector on this side, and I want to find the equation of the line that's the perpendicular bisector on this side. Where those two meet is the circumcenter. Well, to find where those two meet, I have to set the two equations equal to each other and solve. Okay, so I'm going to find the two equations, set them equal to each other. Where they meet, that point, I'll be able to find by setting them equal to each other and solve. Okay, so let's talk about how to find the equation of a line. What's the form? What's the easiest form you guys remember for the equation of a line? Slope-intercept, which is? Yep, this is all Algebra 1 stuff. So I'm going to use this form to find the equation of the line. You can use any form you want. If you'd rather use the point slope form, or if you want to use standard form, whatever you're most comfortable with, this is what my go-to is. But you'll get the same thing. The different forms are up on the blue, purple, green poster. Okay, so in order to find the perpendicular bisector to this, what do we know about two lines that are perpendicular to each other, about their slope? Who remembers? Opposite inverse. Opposite inverse, okay? So if the slope of one line is 3, the slope of the perpendicular bisector is -1/3. If the slope of one line is 2/3, it's -3/2, and so on, right? This should be a review. The slope of a line that's perpendicular to another will have the negative or the opposite inverse slope. Okay, so what I need to do is find the slope of this line, and then I'll just take the opposite inverse of it, and I'll know the slope of the new line. Right? With me still? Okay. What's the slope of this line? How do I find it? Yeah, y2 minus y1 over x2 minus x1, if I've graphed it like this, it's just rise over run. Rise over run. Y over x. Okay, so if I go from this point to this point, how much did I rise? 1, 2, 3, 4. So plus 4. And from this point, how much did I run? 1, 2, 3, 4, 5, 6. Negative 6. Right? So 4 over negative 6 is my slope, which is negative 2/3 when I simplify. With me? So the slope here, negative 2/3, because it goes up 4 to get to this point. I go up 4, 1, 2, 3, 4, and I go over 6. If I go left, it's negative. If I go right, it's positive. If I go up, it's positive. If I go down, it's negative. So I went up 4, left 6, and simplified to negative 2/3. Still good? So I found the slope of this line, but I want the slope of the perpendicular bisector. So what is it? Opposite reciprocal of that. Positive 3/2. Yep. So I found this. It's really hard for me to tell what the y-intercept is from my graph. The y-intercept, again, is where it crosses the y-axis. It's really hard for me to tell. So what can I do to find the y-intercept algebraically? I know the slope, but I don't know the y-intercept. What can I do? Do I know a point on the perpendicular bisector? Where's the perpendicular bisector going to go through? At the midpoint. And I've identified the midpoint as negative 2, 0. So I can use the midpoint, because that midpoint's on this line that I'm trying to find. Right? Y is 0. X is negative 2. So I get 0 equals negative 3, because that's 1, right? Plus b. So b is equal to 3. This is the equation of the perpendicular bisector. Let's see if it works. If I go from this point and I go up 3 over 2, doesn't it cross at 3, the y-intercept? Okay. So if I go ahead and draw this line in, there's one perpendicular bisector. I need to find 2 and set them equal to figure out the point of the circumcenter. You have a problem on big ideas doing this. Okay, I found the equation of one line. Let's find the second equation. Why don't you guys work for a minute and tell me the second equation that goes through this midpoint, 2, 1. I'll pause this.